Excited to be giving a talk on OAuth 2. It's a subject that has been vexing me for a long time in my career. So just jumping into what we're going to be covering today. The birth of OAuth, just give you a little history here. Even show you an implementation in the wild that's still around with NetSuite. And then we'll get into OAuth 2 and like some of its problems. And there's a little tangent in the middle where we talk about a little bit about what makes a good standard, in my humble opinion, of course. And then we'll go into more implementations of OAuth 2, and we'll see about what OAuth 2.1 will bring. So who am I? Well, I'm Shon. I'm CTO, co-founder of Pandium. Just for those who don't know, Pandium is an integration platform built for B2B SaaS companies to streamline their integration build process. We handle the infrastructure and authentication, allowing you guys to all just focus on building integrations that scale and are really deeply embedded into your product. And it's working for Pandium, with Pandium, building Pandium, that got me really into trying to understand OAuth 2. The big challenge for us is building a number of connectors there's like thousands of SaaS applications. And so having connectivity with all of them is really important for an integration platform. And so trying to understand OAuth 2 was really important. I wanted to, understand the standard and then hopefully just roll out what was happening. But I wasn't seeing any patterns when we started to actually get there. And I was starting to wonder, is it me or is it something to do with OAuth? And this led me to like dig into the history and stuff, and hence this talk. So before open authorization, I'm showing a screen here that sort of just shows in a diagram what a user would do to share photos that are stored on a Google Drive with some photo application. If back in the day when this was like probably a relevant example, that photo application was Flickr. And so here you see the user has to supply their username and password for Google to Flickr. And then Flickr, the photo application, the third party, is going to take those username and password and use that to gain access to the user's drive and get all the pictures. What isn't right about this is you're giving third-party access to your entire Google account. You're sharing a password. I don't really have to get into this. This is just bad, right? Nobody wanted this. And so that's what caused OAuth 1.0 to be born. So it came out of a Twitter project in 2007. It was first formally submitted as an RFC in 2008. And the idea was to give a way to access user data in a way that's robust and provides minimum level of access. And so what I'm showing here is a basic OAuth diagram for OAuth 1.0. As an application, you make a request for an access token, for an OAuth token and OAuth token secret. You have to provide a lot of information, a customer key, a nonce, a timestamp, the signature. This was the hardest part with OAuth 1. Once you generate that request, you then take that new token you got. It's not authorized yet. This is what we would now call an access token. It's an unauthorized access token. You provide that to the calling service and say, hey, can you go ask this user if I have permission for these things? And if the user, step 2, actually gives you authorization, you get back that same token. This time now it's verified. With that OAuth token, you then exchange that for our normal access token, and you can just go ahead and make your normal calls. Couple things I want to note here. SSL is not assumed, and that's a big part of why you have an OAuth signature. You have to remember back in 2007, when this was dropped, SSL was something you maybe found in bank websites, but other than that, it wasn't something you would even use on Gmail. And so in order to provide more authentication and security, without having encryption, this signature needed to be created. So what's really cool is there's actually a real life example of a company still using OAuth 1, and that's NetSuite. It's very vanilla with respect to how compliant it is to the spec. It adds scopes and roles to the tokens, and these are totally allowed. They're not in the OAuth 1.0 spec scope or role, but you're allowed to add any key you want. And scope very much is an OAuth 2 thing. What makes it really hard to do OAuth 1 connectors is, and hard is something I would put in quotation marks, is that the signature requires an intricate but very specific algorithm. And so I cut and pasted this from NetSuite's documentation. But if you went and looked at the RFC 5849, which is what OAuth 1 is, it's the same thing. So you have an encoding, you need to make sure it's URL escaped. So like adding those %20s, no spaces. And there's a few other things. The order of the way you construct a signature is really important. Once you have all this down though, it's really trivial to just pass this signature around. Here's an example if you're trying to do a raw request. So one of the things to know is like once you have this token, you have to pass it around along with all that other information. So the customer key, the nonce, the timestamp, the signature, whether you're making RESTful endpoint calls in NetSuite or SOAP endpoints. And just to take a step back, the reason we need to worry about NetSuite's OAuth 1.0 implementation is most of their API is not RESTful. They have 3 different APIs. If you want to have full access to NetSuite systems, you have to use what they call token bearing authentication or TBA, or which is really just OAuth 1.0. With all that said, writing these signatures isn't that hard when you have something like an SDK. Just use the SDKs they provide you. They're really robust. And once you figure out all the specific tokens that you need to create and all that stuff, it's able to just handle all that for you. But this signature, the lack of SSL, made people think, hey, we need OAuth 2.0. And so this led to 2.0. And so why was it thought that OAuth 2.0 was needed? The biggest one was the lack of SSL. OAuth 2 mandates that you do this all over SSL. OAuth 1 did not. The signature writing was too hard. By using SSL, like application developers didn't have to get into intricacies of like figuring out how to do the signature. That's all handled again by SSL. And it's just something that doesn't have to bother the application developer. And the other big thing was mobile devices weren't a thing. So in 2007, that was actually when the first iPhone came out. Steve Jobs holding it up and it not even working happened in 2007. And so when this was being put together for the first time, OAuth 1.0, it just wasn't a concept. How do you log in and do all these things on a really small device with no keyboard and mouse? So before we get into some of the intricacies of this, let's look at a basic OAuth 2 flow. So again, you start as a client, you make a authorization request. This is very much that whole verified thing. It's simplified since you don't need to make the signature. You're just saying, hey, I have this client ID. I'm generating a challenge. Authorization server, what do you got? And it'll send you the code. You exchange that code once you do the dance for an access token. And then midway through this diagram, you can start seeing, hey, I'm using this access token to request things. And the other big part is the refresh token. So you get back an access token and a refresh token. Access tokens are short-lived. They're used to make the actual request. Refresh tokens are longer-lived. They're used to make new access tokens. You store the refresh token, all pretty vanilla stuff. This is for just one flow, though. And this is where we get into some of the craziness. So one of the really interesting things where I was getting into like understanding this story here was like, it turns out there was 33 revisions of OAuth 2.0 just when it got started. It was a really valiant attempt to like bring together industry and get this problem solved. Now we're thinking about mobile. Now we're thinking about SSL. What was very curious to me was that after revision 28, the lead author, Aaron Hammer, he's the guy who wrote the OAuth 1.0 spec and wrote the first 28 of the 33 revisions of the OAuth 2 spec. He quit. He just said that this is no longer what he thought it should be. It was way too complex. He says the standard is bad. At the time, it was just one standard. With very little effort, I'll quote him. Pretty much anything can be called 2.0 compliant. And he's not wrong. With the number of options and the flexibility it gives you, again, in quotes, it's very complex. And it made me think, like, why is it so complex? And so looking at it 10 years later, OAuth 2.0, it came out formally for the first time in 2012. It started immediately after 1.0. And I think that was the first mistake here. There was no time for 1.0 to sit and let people use it. Very few companies were able to get it a 1.0 compliant implementation before 2.0 started. And so what this caused was companies that wanted to move into this new, limited access world, instead of like implementing what was already an outdated spec, OAuth 1.0, they started implementing the revisions of OAuth 2.0. It took 3 years to get OAuth 2.0 formalized. OAuth 1 only took 18 months. It then spawned, because of all the different foot guns and all the different things we could talk about, 20 more RFCs. Just to take a step back, OAuth 1.0, it does have an addendum, 1.0A, but like that is the standard. So at the worst case, you're counting 2 RFCs. That is very small, and it's to clear up a bug found in 1.0. OAuth 2.0 required 20 plus more since then. And it's really hard as a person who's building, for a person who needs to build an OAuth spec, to know like exactly what part of all these RFCs they need to implement and which revisions they're implementing. And it just makes this very, very complicated. And so in our use case, when we're building clients to these OAuth applications, to these third parties, the reason that everything looks different is because you're actually building against someone else's understanding of what OAuth 2.0 is. That understanding may be when it was 10 years old and just starting. It was still in revision phase. One of the first times I even noticed that there were revisions was when I was looking at an API doc, and it said, hey, we built our application to revision 17 of the OAuth 2.0 spec. And I was like, wait, 17? What does that mean? And that's when this rabbit hole opened up for me. And so I'm not crazy is what it turned out. And so this led me to think, like, what makes a good standard? And one of the things you'll notice when looking at specifically RFCs, requests for comments, the way a lot of internet protocols are defined and standardized is this section here on requirements language. So you'll find this almost in every RFC now. It's definition of these words. The definition themselves has an RFC, but the keywords are must not, required, shall not, should not, recommended, may, optional. Depending on the standard, let's just look at a standard. This is OAuth 2, is the authorization request. Depending on the standard, you'll see a lot of requireds. I think those are really strong standards. But then it's when you get into this optional stuff that it really starts breaking down. Like, why is this optional? Why is redirect URI optional? If you go and read section 3.1.2, you're going to have like five paragraphs, 3 pages of information about why it may or may not be interesting for you to add a redirect URI. Scope is optional. That doesn't make any sense. State being recommended. So recommended is theoretically stronger than optional, but they're both treated the same. I see scopes way more often than state inside these authorization requests. And state is really important. It allows you to pass information as a third party through the entire dance and allows you to tie it all together. And so if you're not supporting state, you're technically OAuth 2.0 compliant, but you make it really hard for third parties to work with you. Just going back a quick slide. I like to think of this must and must not and optional and all this as a spectrum. And so that's what this arrow stuff is about. So what makes a good standard? It's the specificity that you get. Those are those musts. It's flexibility. Like you can't always require something. If you require it, no one's going to use your protocol. It needs to be able to work with things out there. But this is where OAuth 2 failed and what Aaron was so upset about. It was way too optional. And because of that, it was way too complex. And so specifically where OAuth 2 stands on these 3 points is like way too many options. So it's not very specific. It's way too flexible. And so therefore really easy to build foot guns. There are like real problems with 2 of the grant flows in OAuth 2 that are specifically like password resource and that just make it really easy to make insecure applications. And then as opposed to simplicity, OAuth 1.0 spec, it's 81 pages. It's not the shortest spec in the world, but it's 81 pages. It's not a lot to read if you really want to understand it. For OAuth 2.0, it's thousands, hundreds of pages, in the thousands. And there's no way anyone's going to read all that and have a full understanding in their mind of all the different things you need to think about. So let's go into some implementation. So again, we're an iPaaS company. We build connectors for a living. And so we have over 200. And so we were able to like pick out like some of the things. So here's Microsoft Azure. One of the things that is really strange about it is you need to have a redirect URI for token refresh, which is bizarre. Nothing specifies why you need that. And it's not anywhere in the standard. They're the only ones who require it. We have a special case if Microsoft Azure connector, add this redirect URL. It requires adding the client ID and token exchange. This is a may step and it's not really clear to me why. It has no security benefit. It's really just to make application development a little bit easier. It's also it's very rare to see it. And so them requiring it, they'll error otherwise if you don't include it, is really interesting. And then they have this particular RFC 7523 it's a RFC for token exchange. It requires adding these client assertions, which are JWTs that have specific meaning. I'll be really super honest. I don't fully grok what's going on here. They're the only ones who've implemented this in our library. And we did it. We got it done. We have to send this a part of it. But again, it's like one of those, like, this person, whoever built it, I'm sure they had a reason why they added all this stuff. But it's not clear to me, based on my understanding of the standard, why you need it. Moving on to another one. Here's Wix. Wix is an older implementation. They call an OAuth 2 solution. So they don't use the word 2.0. It's funny that they use the OAuth 2 solutions, like saying OAuth 2 like or OAuth like. They have 2 flavors. That's what they call their grant flows. One is basic, which is just essentially client credentials flow, where you send a client ID and client secret and you get an access token. It's just like a one-leg dance, essentially. And then they have this thing called advanced, which is a weird mix when compared to OAuth 2.0's off code flow. You have to, in order to refresh, you have to send the client ID, client secret, the current access token, and the current refresh token. Very bizarre. You should only have to usually send maybe a client ID and refresh token, maybe just a refresh token if you're really lucky. And the fact that you need to send all four, it sort of also defeats some of the purposes. You're trying to lower the blast radius of having all your secrets in one place. And here you're giving them all away at the same time. One that I wanted to highlight as actually exemplar is this company called Pleo. They're based in Europe. They do expense management. They implement a specific RFC, proof of key exchange, PIXE, RFC 7636. What's interesting about this is considered best practice currently. You should implement this. And in fact, for public clients, so those are things like web pages that are talking to single page apps. But you should also do it for private as well. And the reason that this was thought to be needed, it is needed, is that it turns out not every interaction is going to actually happen behind SSL. And what I find most hilarious looking at the history of all this is PIXE is just a re-implementation. It's slightly different like protocol in terms of like where you put the different variables and stuff of the signatures in OAuth 1.0. So one of the primary reasons that we moved away from such a simple and awesome 1.0 implementation was because the signatures were too hard to write. But now you have to write the signatures again. And this is best in class. It came out in 2015, and they're the first ones I've seen use it. And their API, I think, around this came out in 2022, 2023. So they're looking at it with a lot of hindsight, but it's just really interesting to like look at the evolution of these things and see like what was the different state of art at different times or people's understanding. And so there's this new RFC coming along. It's called OAuth 2.0, 2.1. The idea behind it is they're going to take all of the RFCs and all of the best practices and all of the thoughts around OAuth 2.0, combine them, distill them into one document. And so you end up having to only read one document. The idea is after you read the RFC for OAuth 2.1, you do not have to read any of the other RFCs for OAuth to create safe and correct implementation. So some of the biggest things they got rid of and really helped simplify the spec is there's no distinction now between public and private clients. Everything is a client. You should do all the same things for all clients. It doesn't matter. PIXE is required. As I mentioned before, PIXE is should for public and recommended for private in 2.0, but 2.1, you have to do it. And it makes sense to me. The reason you have to do this, it turns out that on an iOS, on any device where you're able to open links that open an application directly, say like a GitHub link. I have GitHub on my phone. If someone sends me a GitHub link, it'll open up in the GitHub app. It turns out if someone was to register a GitHub app or the URLs that GitHub would use and puts that into a malicious application that I then download onto my phone, that application can end up stealing parts of the flow, like the access code or the access token that's returned, and use that to make subsequent calls. So that's why PIXE was added. PIXE prevents you from all the secrets from being in one place. And so it just allows you to make secure calls without even having SSL. It secures redirects. So like there's a lot of shenanigans you can do with playing around with redirects. And by locking these down, it helps. This makes my job as an iPaaS provider a little bit harder, but it's in the right direction. Unifies all the RFCs. I already mentioned this. So this would be the one RFC to read if you implemented OAuth 2.0, 2.1. It removes some really problematic grant flows that are super insecure, including user password grant and resource password grant. I may be mixing up those names. They're too similar. There's like 6 grants. And then it enforces limiting of refresh tokens, which this one actually scares me a little bit because one of the biggest issues we face at Pandium is sometimes, depending on how the partner implements their refresh logic, you can lose the refresh token and then the end user has to reconnect. And so this leads me to what I like to see in the OAuth 2.1 spec. And one of the biggest things for me would be around not invalidating refresh tokens until they're used for the first time. So during an exchange for a refresh token, the partner system can generate a new token in their database, commit that to their database, and then send that to the requester. The problem is sometimes that send to the requester fails. There could be some network fault or something. And so you've now invalidated the old refresh token and not actually given the end user a new one. And so in my world, if I had one wish, it would be, no, you keep the original refresh token that was used open. And as soon as the new one is used, that's when you close the old refresh token. And this will just create systems that are a little bit more robust without, I think, degrading security at all. And what's really interesting is I'm actually going to use this as opportunity to enter the RFC process. And so see if I can get this into the RFC standard. It's scary. I've never tried to do this before, but it's something I'm interested in trying. And so there's also another ideas, right? So there's this whole idea of grant negotiation authorization protocol. It's like, what if we don't use OAuth? What if we just start all over? And reading through that RFC, it just makes me think of this classic XCKD where it's like, hey, we have all these different standards. Let's make another one. And now you have a 15th one. And so now you have to clean this all up. OAuth 2.1 ostensibly is in the same vein here, but I think by not trying to just start all over, I actually appreciate what they're doing. They're just codifying the best practices after letting this OAuth float. Now it's been, if you count all the way to OAuth 1.0, 17 years, right? So we've, wow, that's a really long time. We have 13 years. No, it is 7. Yeah, wow. It's 14 years. If you are trying to make something better, it's good to have the stuff that's in usage out there and actually see it in practice before you're trying to make it better. And I think that was if I had one thing, it was OAuth 2.0 starting right away. I think OAuth 1.0 needed to bake for a few years before we tried to do that. Cool. At Pandium, we take a lot of pride in educating our customers and audience and all the integrations and APIs. Here's one of our most popular resources. It's 400 companies and their different integration strategies. Definitely download that. And I just wanted to thank you all for the time.